Good morning, good afternoon, or good evening, depending on where in the world that you are. Welcome to today's Feedstuffs webinar, Managing Mycotoxins, Impact on Enteric and Foodborne Pathogens in Poultry. This webinar is sponsored by dsm-firmenich and broadcast by Informa. I'm Sarah Muirhead, and I will be your moderator here today. Before we get started, a few just a few housekeeping things to talk about here. This webinar is interactive. There's a docket of widgets at the bottom of your screen that will allow you to learn about today's speakers, download resources, share this webinar, and participate in the Q&A session that takes place at the end of our presentation. The slides will advance automatically throughout the event. Towards the end of the webinar, we will ask you to complete a survey. Please take a minute to fill this out before leaving us today, as your feedback will provide us with valuable information on how we can improve future events. Lastly, if you experience any technical problems, please click on the Help widget at the bottom of your screen or type your issue in the Q&A area, and we will gladly offer one-on-one assistance. Now, on to the presentation. Managing Mycotoxins, Impacts on Enteric and Foodborne Pathogens in Poultry. Discussing today's topic is Dr. Chasity Pender, Technical Service Manager at dsm-firmenich, and Dr. Revathi Shanmugasundaram. I'm sure I didn't get that right. You'll have to correct us here. Research biologist in the Toxicology and Mycotoxin Research Unit at USDA-ARS. To learn about our speakers, please visit the speaker widget at the bottom of your screen. Now, as we get started here, we want to kick off with a polling question. So let's go ahead and put that up on the screen. If you would please take a moment to answer that question. The question we're asking is, do you currently test for mycotoxins? A very simple yes or a no. We'll give you here about 15, 20 seconds to go ahead and just check that if you would. That just gives us some background as we get going on our discussion. So please take a moment and check yes or no as to whether you currently test for mycotoxins. All right, let's go ahead and see what our answers are. So we have approximately 64.5% of you that do already currently test for mycotoxins. Very good. All right, let's get started with our presentation. We have Dr. Chasity Pender of dsm-firmenich, and she's going to talk about mycotoxin sampling and analysis, insight into 2023 crop contamination. Over to you, Chasity.
Thank you very much, Sarah. I'm very excited today to share with you the February update of our annual corn survey, which is a survey that we've been doing for we've just made our 20-year mark, actually. For 2 decades, we've been doing this survey looking at mycotoxin contamination in each year's corn harvest. So let's go ahead and get started. So all of the samples that we use for this survey were analyzed by Romer Labs using their LC-MS technology. So here in this table, you can see the list of 18 different mycotoxins and mycotoxin metabolites that they test for. You can also see the limits of detection that are here in this column. I will like to point out that as of August this year, Romer has updated their methods to what they call the PLUS method, where they have enhanced their efficacy, their sensitivity for this analysis. And so thus we have new levels of detection that you can see in this column. And they've also added in limits of quantification or quantitation. Now, because of this change, I will like to point out that when you look at the results of the survey, there are going to be a little bit of differences, or maybe some more drastic differences when you look at historical references. If we look from the 22 corn harvest and previous, it will look a little bit more dramatic because of this increased sensitivity. So I just want to point that out in case you notice that there are some big changes, and just note that those are due to changes in the analytics and not the results per se. And I'll go ahead and point those out again when we get to those slides. So let's start with occurrence in the 2023 US corn harvest. So when I speak of occurrence, I'm talking of how many of those samples, what percentage of those samples that were submitted for the survey tested positive for one or more mycotoxin. So if we look here, I'm going to be focusing on the 2023 year, which is this farthest gray column to the right. You will note that so far to date, we have analyzed 189 corn samples from across the United States. If you look at each one of these colored lines, I'll point out that the dark blue line is for fumonisin. This purple line is for zearalenone. The green line is for B trichothecenes. That includes like T2, HT2, deoxynivalenol. This light blue bar is for A trichothecenes. Sorry, that would be for your T2s, HT2s. And then this, we'll call it salmon colored line, aflatoxin. And this olive green color is for your ochratoxin. And that's going to stay consistent across the different slides that I show you coming up. So if we look at our fumonisins, you can see that there was a slight increase looking from last year, 79% to 86% is what we saw this year. For our B trichothecenes, again, this is your deoxynivalenol. We went a little bit down, going from 68% this year to 59% of our samples testing positive for B trichothecenes. Now, if we look at zearalenone, again, this is that purple bar. We went from 31% last year to 76% positive this year. I put this little star here because this is predominantly due to the change in analytics. Because we do have a lower limit of detection now with this plus method, we are hitting a few more samples coming back positive. So I think that is a little bit exaggerated, but just wanted to point out, but 76% of our samples this year have tested positive for zearalenone. And in a similar fashion, we went from 3% to 21% for our A trichothecenes. And again, I think that's due to the analytics here, but 21% of our samples have tested positive for A trichothecenes. For aflatoxin, we appear to be holding steady at about 11% compared to last year. And then ochratoxin, again, we don't have that many samples test positive for ochratoxins in the United States. So far to date, we haven't had any samples test positive or very few samples test positive in the grand scheme of things, which is similar if you look year over year. We don't tend to have very many samples test positive for for ochratoxin at all. So let's switch to the mean of positive. So of those samples that tested positive, what was the average contamination for each one of those mycotoxins that we tested? So if we look at our fumonisins, about 2.5 ppm is about the amount of fumonisins that we're finding positive in these samples this year. It does look like we have a little bit of a typo here, so just to point that out, that's about a little over 3.5 ppm. There should be another number here. For our B trichothecenes, we're trending upward, where we have about 1.5 ppm in our samples that we're testing positive. If we look at our zearalenone, it looks like we're trending downward, going from 329 ppb to 117 ppb in this year. Again, I think that's due to the analytics. Now that we have a lower level of detection, we're picking up more samples at that lower level, and I think it's pulling down our average, and that's similar for the fumonisin numbers as well. And though we're not seeing a very drastic decrease in our A trichothecenes going from 57 ppb to 47 ppb this year, again, I think that's again to the lower levels of detection that may be dropping and pulling down that average this year. If we look at our aflatoxin, we look like we're trending downwards from 46 ppb that we saw last year on average to 20 ppb this year. And then if we look at our ochratoxins, we had very low levels last year, only an average of 4 ppbs, and this year, again, we haven't had any samples test positive in the 189 samples that we've analyzed thus far this year. Now, we've pointed out the averages. I want to also bring in the maximums to kind of give you an idea of what type of range we're looking at in terms of contamination levels. So here I've just kind of color-coded these stars to give you an idea for each one of the mycotoxin groups, what the maximum value that we've been seeing. So fumonisins, though we saw an average of just over 2.5 ppm, The maximum that we had come in was over 48 ppm. For our B trichothecenes, again, this would be like our deoxynivalenol, we had an average of 1.5 ppm. Our highest value that we had come in was over 10 ppm. For our zearalenone, we had a maximum of just under 2 ppm. For our A trichothecenes, our maximum was 300 ppb. And for our A trichothecenes, our maximum was 157 ppb. So let's break it down now by state. And this is really where I like to dive in a little bit more and kind of see what we're looking at on a state level. All the numbers before, we're kind of looking at a congregate on an average on a country level. But really, as you know, the climate, the environment is going to be completely different based on which state that the corn is grown in. So this is really where I like to take a deeper look and breaking it down by state. So to kind of give you, or to focus your attention down here on this bottom left, to give you a key on how to read these maps, if you see a red color, that is a state that had an average of over the threshold we have indicated. So this is for aflatoxins. So for aflatoxins, the threshold we used was 20 ppb. If you see a yellow color, that means it's a state that was below the average for the threshold we set. For aflatoxins, it's 20 ppb. If it's a dark gray, that means of the samples we tested, none of them came back positive or above the level of detection. And if it's a light gray color, that means we did not have any samples sent in from that state. So here we have aflatoxins, and I do like to point out the table to the right as well. This breaks it down by state. You can see how many samples were tested in that state. We like to be full disclosure here. So if, say, 100% of the samples came back positive, but we only sampled one sample, that kind of gives you an idea of what type of weight to add to that piece of data. We have the number of samples that were tested, the percent positive of those samples, and what was the average for that state. So right now, when it comes to aflatoxin, Georgia seems to be leading the group. We've only had 2 samples tested, with 50% of those samples testing positive, with an average of 48 ppb for aflatoxin. Missouri, this one we have the most number of samples, 35 samples in total. About a quarter of those have been testing positive, with an average of 35 ppb, or parts per billion, of aflatoxin. Next, we have our type B trichothecenes. Again, this is your deoxynivalenol. The table down here, or the color coding down here is going to be the same, except in this case we have a threshold of 1,000 ppb. So for B trichothecenes, Ohio seems to be leading the group, with 100% of the samples sent in testing positive, with an average of just over 5 ppm of deoxynivalenol, which is quite high. And that's followed closely by Florida. Though we've only had 3 samples sent in, 100% of those samples have tested positive for just under 5 parts per million of B trichothecenes. Next is fumonisins. I will say, looking at the survey year after year, I do find this, the map, quite interesting. Usually I consider fumonisin a more southern mycotoxin, as it tends to like drier, warmer climates. So usually there's a nice white line, nice clean line going right across the I-70 line. We're below that line, we tend to have more red, we tend to have higher levels in those southern states, and lower levels as we go farther north. We're not quite seeing that just yet, but I think as we get more samples in from those more southern states, this may become clear and looks familiar to what we usually see year after year. So for fumonisins, Colorado so far is in the lead. We've had 10 samples sent in. 100% of those samples have tested positive, and we're just over 9 parts per million of fumonisins in those samples. And Missouri, not far behind. We have many more samples there. 97% of those samples testing positive at just over 5 parts per million of fumonisin in those samples. Zearalenone, for here, our threshold was 100 parts per billion. This one tends to show up a little bit higher up in those New England states and around the Great Lakes, and we're seeing that again this year. Vermont, we've had one sample come in. It was positive at 951 parts per billion of zearalenone, which is quite high when it comes to zearalenone. Pennsylvania is second with 2 samples set in, with 100% of those samples an average of 662 parts per billion. And then Ohio coming in with a large number of samples, so 16 samples, 100% of those samples testing positive for 440, an average of 440 parts per billion. And then we have our type A trichothecenes. Again, because of those lower levels of detection that we're now able to use because of the PLUS method, we are seeing quite a few more positives come up. So right now, Minnesota, we've had 3 samples come in from Minnesota, with 33% of those samples testing positive with 192 parts per billion on average for your A trichothecenes. And we also have Michigan following close behind with 4 samples and about a quarter of those testing positive for an average of 139 parts per billion. And I will say with type A trichothecenes, the mold that produces these tends to like colder climates. So we don't tend to find higher levels down in the States. As we get farther north and we actually get into Canada, we start seeing higher levels of those type A trichothecenes. So co-occurrence trend, this is looking at the number of samples that test either below the level of detection, which is indicated here by this green line. They test positive for 1 mycotoxin, which is indicated by the yellow line, or they test positive for more than 1 mycotoxin. That's indicated here by this orange bar. So if we compare to their past year, our samples that are testing higher for more than 1 mycotoxin, again, this may be related to the number or to the lower level of detection that we're seeing. We do seem to see an uptick from 69% of samples testing positive for more than 1 mycotoxin last year to 79% testing positive for more than 1 mycotoxin this year. And coincidentally, or because of or as expected, we're seeing a decrease in the number of samples testing positive for 1 mycotoxin, as well as those samples testing below the level of detection. Now, if we look at the profile of that co-occurrence, so we're looking at which mycotoxins are testing positive together. This is something we started doing a few years ago, and I always find fascinating of which mycotoxins are commonly showing up together. So I'm actually going to start over here on the right and look at those samples that tested positive for greater than 2 mycotoxins. We actually had 58% of our samples test positive for greater than 2 mycotoxins. And if I look at which mycotoxins are commonly showing together, it is the combination of your B trichothecenes, fumonazins, and zearalenone, with 33% of our samples testing positive for that combination. If I look at 2 mycotoxins, so we're going into this darker orange, we had 22% of our samples test positive for 2 mycotoxins, with the combination of fumonazin and zearalenone showing up the highest at 12% of our samples. And then with only 1 mycotoxin, 15% of our samples tested positive for 1 mycotoxin, with fumonazin leading with 13% of the samples testing positive for zearalenone, or sorry, for fumonazin alone. So just to kind of summarize what our survey results are telling us to date, so far we've had 189 corn samples submitted from 19 states. 95% of those samples have tested positive. This is a slight uptick from what we saw last year, which was 92%. If we look at co-occurrence, we do see an increase in the percentage of samples testing positive for greater than 1 mycotoxin, going from 69% last year to 79% this year. If we break it down into the major categories, looking at B trichothecenes, we are a little bit down from last year, from 68% last year to 59% this year. If we look at our contamination rate, though, we do see an increase from just over 1 part per million last year to 1.5 parts per million this year. For fumonisin, we are looking on an upward trend from 79% last year to 86% positive this year. But if we look at our contamination rate, it actually looks like it's gone down from last year, where we had just over 3.5 parts per million last year. And now we're at just above 2.5 parts per million this year. For zearalenone, we seem to be trending upwards from 31% positive this year to 76% positive this year. And again, I think that's a lot due to the level of detection and our test being a lot more sensitive now with the PLUS method. And if we look at our contamination load, we were at 329 parts per billion last year. This year, we are at 117 parts per billion. And again, we do want to point out that we did have a change in our analytics. So we do have lower limits of detection, and that's going to influence our comparisons if we look to last year's levels. So we may see increased occurrence and lower averages. And so far, the mycotoxin groups that seem to be mostly affected are going to be our zearalenone and our A-trichothecenes. This is just our February update. We update our survey monthly, and actually we should be having an update come out next week for our March update. So we're going to continue monitoring the corn as it comes in. So we're going to continue monitoring and surveillance, and let's see what this corn harvest is bringing us this year. So with that, I'm going to conclude my portion of the presentation. I look forward to addressing some of your questions at the end. And that's going to bring us to our second poll question. Sarah, I'm going to go ahead and pass it on to you.
Very good. Thank you so much, Chasity, for sharing that very important information. As you indicated as well, go ahead and put any questions you might have in the Q&A widget. We're certainly interested in getting those and to see what you're thinking about and what questions you might have. So now we are on our second poll question. What mycotoxin or mycotoxins are you concerned about? You can select as many as you like in that list. I'll give you another, few seconds here, but if you could go through and just mark those that you're concerned about this year, that would be great. Those that you really are watching and monitor. And then we'll go see where we're at in terms of what you all are concerned about. So I'll give you just a couple more seconds here. Still a little time if you want to post any questions you might have. Actually, you can post them at any point that you'd like to throughout the presentations, and we will answer those questions at the end. All right, let's go and see where we're at in terms of the answers to this poll. Looks like aflatoxin is coming in the strong first, and then you can see the breakdown on the rest of those. I'll leave those up there just for a sec as we move forward to our next presentation. So thank you for putting your input in there. Now we're going to turn it over to Dr. Reva from USDA as she shares her presentation on the impacts of mycotoxins on enteric and foodborne pathogens. Over to you, Reva. I think you're on mute.
I'm sorry. Good morning, everyone. It's an absolute pleasure to be here today and share my research with all of you. And I saw the poll answers, and it's absolutely no fumonisin is here, no primary concern. And I'm going to share some of my fumonisin and DAWN research with all of you. Before that, why mycotoxins matter to the poultry industry? So understanding the importance of mycotoxins in the poultry industry, first we should understand the major economic drivers of an integrated poultry system. One of the major cost component is that feed ingredients, which accounts for approximately 60% of the total production cost. In the poultry industry, corn serves as a primary feed ingredient, contributing to nearly 65 to 70% of the chicken diet. So to understand the importance of corn, let's take a look at the typical chicken feed composition. So if you look at the table on your right-hand side, in a standard feed, which is a corn, soybean meal-based diet, corn alone makes up to 55% of the feed composition. In certain cases, such as just pure corn-based diet, corn alone contributes 72% of the chicken feed. So mycotoxins, which are secondary metabolites, has the ability to contaminate your feed ingredients, starting from cultivation, harvest, transportation, and of course, during storage. So based on those, we can categorize these mycotoxins into field mycotoxins or storage mycotoxins. And if you can pay attention to the first table on your left-hand side, whether it is a storage mycotoxins or a field mycotoxins, the poultry feed ingredients like a corn, wheat, barley, soy contain all 6 major mycotoxins. So the point here is that the feed is the key player for introducing mycotoxins into your poultry flock. Of course, FDA has set regulatory guidelines for maximum permissible level of fume, DON, and aflatoxin. For example, 50 ppm is the maximum permissible level for fumonisin, and 5 ppm is the maximum permissible level for deoxynivalenol. Here, I would like to point out that these guidelines are for just individual mycotoxins. For example, if the feed is in an ideal condition with just one mycotoxin is present, this is perfectly fine. But with our previous speaker, Dr. Pender's presentation, you may notice that at least 79% of the samples had more than one mycotoxin. So we should consider the co-occurrence of multiple mycotoxins, which is really important in poultry production standpoint, because mycotoxins, they have a synergism or additive effect. So the combined impact of mycotoxins will be considerably greater than that individual mycotoxins. So what would happen if the chicken consistently ate mycotoxin contaminated diet? In chickens, generally, the conversion of certain mycotoxins, we call it as a biotransformation, basically removes or break down their chemical structures by microbes, which takes place at the ceca after having they passed through all the major absorption site. So this microbial degradation is not that much beneficial to the chickens because DON, fume, or any mycotoxins, they have already damaged that small intestine by the time these mycotoxins reached the cecum. And top of that, each mycotoxins have a varying bioavailability. For example, some of them will be more absorbed more quickly, like aflatoxins. Some of the mycotoxins, like DOD or fumonisins, they have very poor bioavailability. So they can pass through along the digestive tract. The point here is that whether the mycotoxins absorbed into the systemic circulation or not, the cells in the GI tract exposed to these mycotoxins at highest concentration. So in general, the impact of mycotoxins on farm animal production performance are generally well known. In the past, previous researchers, they have done tons of research with just toxic dose of mycotoxins or different combination of mycotoxins. And then they observed that, decrease in production performance or reproductive performance and compromising that immune functions or organ damage. As I said before, this intestinal tract is the first site of contact, and the intestinal epithelial cells are the very first target cells for the mycotoxins. We do not know much about the kinetics and the metabolism of the mycotoxins when they pass through the digestive tract. considering most dietary mycotoxin solutions will act on the mycotoxins in the gut, it's really, really important to understand the time window for actions available within the gut. For example, how readily these mycotoxins absorbed in the GI tract, what concentration reached into the various organs, or how long the mycotoxins and metabolites stay in the body. These aspects are primary importance in terms of biological effect and also for risk assessment. So what is the importance of intestinal epithelial cells? Basically, these cells create a barrier between the gut lumen and the body tissue. So intact tight junctions basically seals the space between the epithelial cells so that unwanted particles, pathogens, toxins, they are not allowed to enter into the blood circulation. But mycotoxins targeting these cells, several intestinal functions are compromised, like leaky gut syndrome, meaning that intestinal lining become more porous, so the barrier function is no longer functioning properly. So this damaged intestinal junctions, letting the pathogenic bacteria to enter into that blood circulation. So this influences the carcass contamination in the slaughterhouse. In addition, this bacterial translocation can be responsible for onset of certain infectious diseases like subclinical necrotic enteritis. So here is the data from 6 necrotic enteritis trials. So each trial was repeated at the same settings, but the only difference was that feed. Feed comes from different sources. So if you look here, each trial, the necrotic enteritis lesion score was different. And if you pay attention to this table, the amount of mycotoxin from each trial is different. And this reflects on that intestinal lesion score and also in that gut integrity. So mycotoxins, basically, they do not have a direct impact on that Clostridium perfringens, which is the main causative agent for the necrotic enteritis. So they don't have a direct effect on their proliferation or toxin production, but what they do, these mycotoxins basically affect the gut health integrity, decrease the absorption of the dietary proteins, and these proteins serve as a nutrient for these Clostridium perfringens. So basically, these toxins creating a favorable environment for pathogen to grow. So in the past, fumonisin below 50 parts per million and DON 5 ppm were considered not to cause negative effect in chickens. But with the fast-growing modern chickens and the co-occurrence of multiple mycotoxins, we do not know what is the lowest concentration that will cause this economically important disease, necrotic enteritis. So our goal was to evaluate the role of these Fusarium mycotoxins on development of necrotic enteritis in chickens. The question we had was that, is the damage caused by these Fusarium toxins is big enough to cause necrotic enteritis? Even without this coccidial pathogen, this coccidia is another predisposing factor for this necrotic enteritis. So we used a different concentration, different combination of mycotoxins within that FDA permissible level, starting from this 21 ppm of fumonisin and then the 3 ppm of DON to lower down to 1 ppm of human DON. So as you can see here, the significant treatment effect on the body weight gain even from the day 21, and this trend continued until day 35. So interestingly, on day 35, the highest dose of this combined fume and DON decreased the body weight gain by 132 grams. And the other thing we noticed was that whenever the fume was combined with about 2 ppm of DON, it significantly decreased the body weight gain by 103 grams and 75 grams. So in our another trial, we used 10 times less than the recommended level of fume and DON. So we used 3 ppm of fume and then 4 ppm of DON. So there were a significant treatment effect on body weight gain on day 14, 21, and 35. The interesting thing we noticed that on day 14, these toxins decreased the body weight gain by 39 grams, and this trend continued until day 35. The chicks in the fume and DON alone group had an 84 grams decrease in the body weight gain. This is approximately 5% of the body weight loss, just because of that fume and DON alone. When we think about this, poultry margins are always limited. So we should consider that these tiny losses tend to be much costlier over a long period of time. So we also quantified that feed conversion ratio, and as you can see here on day 14 and 21, there was a significant differences, very similar to what we saw in the previous slide. So on day 14, this fume and DON group had 8-point increase in the FCR, and on day 35, this fume and DON combination increased the FCR by 3 points compared to that mycotoxin-free groups. Here are some more visual lesions. As you can see on the image, lesions are mostly on the distal part of the jejunum and the proximal part of the ileum. The first image is what you see is a score of 1, mild lesions as the intestine are filled with mucus. And the image in the middle had a velvety appearance and it was scored 2. And the last image is that scored of 3, where the intestinal content filled with blood-tinged intestinal content. As you can see here that this subclinical dose, the 3 ppm of fume and 4 ppm of DON combination increased the lesion score compared to that control group on day 21. So the tight junction protein, as I mentioned earlier, these are adhesive junction molecules, basically keep the gut epithelial cells together. These proteins are really critical in terms of controlling the intestinal permeability. Basically, they facilitate the passaging of ion solutes intracellularly. But at the same time, they block the entry of unwanted microorganisms, antigens, or toxins. As these mycotoxins targeting these tight junctions, we measured these tight junction molecules. In our trial, we found that claudin, occludin, and zona-occludin were significantly decreased in the fume and DON combination groups. Here are some of the intestinal histology pictures. The image on your left-hand side is the control group. You can see that clear intact villus and crypt. The image on your middle is from the mycotoxin contaminated group. You can see that the tip of the villus is heavily compromised. But when the fume and DON is present, and especially when the birds are undergoing necrotic enteritis, the villus is completely destroyed. No, it was very difficult for us to identify one single intact villus. So in my opinion, there are no safe or unsafe level of mycotoxins. Even low level of multiple mycotoxins are equally dangerous. Here is the relative abundance of main bacterial families in the ceca, because we wanted to know whether these gut microbes in the chicken has the ability to detoxify these mycotoxins. So I'm not going to go too much into this, but the take-home message from this graph is that mycotoxins significantly increased that the lacnospiraceae, which is that dark red color box. So this lacnospiraceae family seems to be the hallmark for the exposure of the chronic doses of human DON because these family is responsible for some intestinal disorders in other species. And the other most important thing I wanted to point out that these dietary mycotoxins decreased the lactobacilluses relative abundance, which is a gray color box. But on the other hand, it significantly increased the Clostridia family, which is a light blue box. You all know that lactobacillus is known for detoxifying mycotoxins. But in our case, switching that lactobacillus to Clostridia might be involved in poor detoxification of mycotoxins. So this may cause dysbiosis and causes dysregulation of mucosal immunity. As a result, you may see subclinical necrotic enteritis in your flock. We also looked at salmonella load in the cecal content. In this study, we used 14 ppm of fumonisin and 0.6 ppm of DON. Surprisingly, in our mycotoxin contaminated feed, we found that other kind of mycotoxins like T2 toxins and neosolenol, which is an emerging mycotoxins. As you see here that even the subclinical dose significantly increased the salmonella load by 1.5 logs. So in summary, when it comes to the feed, what we give to the chickens, it is important to remember that there are many different things we mix it together in the chicken feed. So just testing one part of the feed might not tell us everything about how safe the feed is. We found that having more than one mycotoxin in the feed that can really hurt the chicken production performance. Even small amount of mycotoxins, like if 3 ppm of fume and 4 ppm of DON, can start make things worse for the chickens. So this can affect the important things in their biological system of the chicken, like how their GI tract work and how many beneficial bacteria they have, things like that. And also the co-occurrence of multiple mycotoxins can make it easier for foodborne pathogen like salmonella to grow. So it is really important to keep an eye on what is in the chicken feed to keep them healthy and growing strong. So it's like, we have another, poll questions. I'm going to hand it over to Sarah.
Very good. Thank you, Dr. Reva, for a very informative presentation. As she mentioned, there's another poll question up there. This question is, what approaches do you utilize to mitigate mycotoxins in your operation? And there's a couple of answers. Go ahead and select all that apply there. We'll give you a few seconds to go ahead and answer that. A reminder that if you have any questions for our speakers, you can post those in the Q&A box on your screen. You've got the experts here, so it's a really great time to get some insight on any questions you might have on this topic. So a reminder, I'm going to give you just a little bit longer. Go ahead and answer that poll question that is on your screen about what approaches you currently utilize to mitigate mycotoxins in your operation. All right, let's go ahead and see what how the answers are coming out here. There you can see that. It looks like the number one approach that is used is to screen feedstuffs to reject contaminated feeds prior to purchasing, which is always something smart to do. I want to thank all of you for your participation in this poll, as well as our other polls here today. Please direct your attention to, there's a webinar survey down at the bottom in your docket of widgets, and we'd like you to fill that out so that we can make sure that we're providing you with webinars that are of interest and of value to you. Now on to the Q&A portion of our event. We are going to take some questions here that you've given us, and we would like for you to continue to give us any questions that you might have. All right, so let's start with you, Chasity. Do mycotoxins affect broilers, turkeys, layers, broiler breeders the same way, or do some bird types or even breeds deal with mycotoxins better than others?
Thank you very much for that question. I would say yes and no. So in terms of the mycotoxins, the modes of action are the same regardless of which subspecies we're looking at. If we're looking at layers versus broilers versus breeders, for example, so their effects are going to be quite similar, but there are going to be different sensitivities amongst the different groups. So if I had to kind of put them in order, your turkeys are going to be the most sensitive, then followed by your broiler breeders, and that's mostly just because of one, we're working with a breeding animal, an animal that's in its reproductive stage. So zearalenone is going to have more of an effect, but you also have a longer lifespan. So you can now look at chronic exposure over a longer period of time. And similarly then would be your layers, because they can be exposed to mycotoxins on a chronic type situation because they are longer living, and then followed by your broilers, mostly just because they're short-lived. You're not dealing with the reproductive system. So hopefully that answers your question. Yes and no.
Very good. Does DSM have a document with the historic data on the number of samples per state? Do you have anything like that that gives kind of a summary?
Yeah, so if you go to the website, DSM website, all of our monthly updates are posted to that website. And there should be previous years as well. So if you want to go back to the 2022 corn harvest, that should be posted on there. And it'll be very similar to what I've shown here with the breakdown by state. I'm not sure how far it goes back, but we have a very large database, an extensive database of historical data that we can mine. So we can go pretty far back. If there's particular years that you're interested in, particular states that you're interested in, we'd be happy to do a little bit of mining for you.
Very good. So Reva, it seems like we're continuing to understand the health impact of mycotoxins. Is there research exploring new areas, diseases of mycotoxin impact?
Yes. Currently, no, as I said before, that the chickens are dealing with mycotoxins in a different way. The gut microbes, they break down their structures at the last part of the gut. So most of the time we know the effect of mycotoxins after the fact, when we see that no vaccination failure or decrease in production performance or necrotic enteritis, at that time we will go and test the feed. So currently we wanted to know whether we can able to detect this mycotoxin exposure without destroy or kill the bird. So in our lab, we are focusing on that, identifying that some microRNA biomarkers. So with that, just with the blood, collecting the blood from the bird, and we can do some kind of microRNA to detect this mycotoxin exposure. And also on top of that, we are also focusing on developing vaccines targeting multiple mycotoxins at the same time, as feed is contaminated with more than one mycotoxin. So those are all the research currently going on.
Kind of brings us nicely into the next question that I'm going to send over to both of you. Reva, we'll have you start with it. Since co-occurrence is so common, how does that change how you should think and manage mycotoxins?
That's really a good question. So my first advice, or first advice is that we have to, because the mycotoxins are produced by molds. You can see that molds, but definitely you don't see that mycotoxins in the feed. So we have to store the feed in the farm in a right way. The quality control is the key thing, in my opinion. So whenever you receive that new feed materials, just to test it right away. so that if you detect the contamination level is above the guidance level, the farmers can reject that raw materials. And the second thing is that the proper hygiene measures at the farm level, so which is really, really critical. For example, on a daily basis, cleaning the feed troughs. That will prevent that any residue of feed which is present in the feeder that will easily get mold. So just pay more close attention to those kind of things. And the another thing is that pay attention to that birds' production performance, monitor them closely. So if you see that any small symptoms, instead of doing all other things, just to go and test that feed. Sometimes we forgot to understand that feed is the root cause of so many other problems. So test that feed. So that's my opinion. So Chasity, do you want to add more on that?
Oh, yeah, sure. So you definitely hit on quite a few of the spots that I was going to hit on. The only thing I'd like to add is, because co-occurrence is kind of the rule of thumb, it tends to be the case more often than not, is just making sure if you are implementing a mycotoxin mitigation strategy, that you're choosing one or multiple strategies that addresses that wider scope of mycotoxins that you're going to be coming across. You don't want to pick one mitigation strategy that only focuses on one particular category of mycotoxin. You want to have a wider scope to be able to protect you against those other mycotoxins that are inevitably going to be present.
So Chasity, for someone who doesn't currently test or treat for mycotoxin, what does good mycotoxin risk management look like?
Oh, that's a good question. I would say when it comes to mycotoxins, it's better to be proactive than it is to be reactive. So making sure you have some type of mitigation strategy in place, because usually by the time you figured out that you have a mycotoxin issue, it's going to be very hard to rebound from that. So as I said, it's better to be proactive than reactive. And then, as Dr. Reva mentioned, being proactive when it comes to your testing, know what's coming in into the feed mill, what's going to the bird. So looking at not just corn, I know we present the corn survey, but we do a lot of other feed ingredients in feed as well when we do our testing. So looking at what's coming into the feed mill, what's going out into the feed, what's going to the birds, and what they're actually being exposed to help you kind of create the best strategy for your particular situation is really what I would do.
And one probably final question here. How do you know if your mycotoxin program is truly working? Chasity, you want to take that one, and then we'll go over to Reva if she sees if she has anything to add.
I'd say when I've received that question a couple times in my career, and I always say the birds will tell you. The birds will tell you. The birds will tell you if there's an issue, and the birds will tell you if we're hopefully helping mitigate those issues. But I will say sometimes, especially when it comes to broilers or breeders, depending on the impact, depending on like how big that exposure was, sometimes it's too hard to come back from. So that's why I would say be proactive and have something in there to hopefully prevent it. So hopefully the birds are just performing well and you don't have those dips. But if in the case that you are trying to be more reactive, in hoping that the exposure just wasn't too great, that the birds will tell you that things are getting better. They're going to start eating again. They're going to start, their growth is going to start compensating. They're going to start performing better. So that would be my answer to that question. Dr. Reva, did you have anything you wanted to add?
Yeah, sure. You answered all. And also on top of that, if the farmers are willing to do that, they can take the feed during that during their lifespan. For example, at the beginning or at the middle of their program or at the end of their feeding thing, they can collect some feed and then they can analyze that is there any increase or decrease that amount of mycotoxins in the feed. And also on top of that, they can they have to monitor that whether the vaccination works good, whether that feed intake, how the birds perform well, to make sure all sort of things, and just to understand that if the bird is not performing good, just first thing, just to test that feed. That's my suggestion.
Very good. Well, that's all the time we have for questions here today. I want to thank both of our speakers. We appreciate your time and your expertise on today's topic. Thank you as well to our sponsor, dsm-firmenich, and everyone in the audience. We thank you for tuning in and for your attention and your participation. Within the next 24 hours, you're going to receive a personalized follow-up email with details and a link to today's presentation that you can view on demand. Please feel free to invite your colleagues and peers and whoever may not have been available to listen to the event to go ahead and tune into that. There's some great information here, as you all heard today. This webinar is copyrighted 2024 by Informa. The presentation materials are owned and copyrighted by Informa Markets. Individual speakers are solely responsible for their content and opinions. On behalf of our guests, Dr. Chasity and Dr. Reva, we appreciate you being here today. I'm Sarah Muirhead. Thank you for your time, and to all of you, have a great day.